we are going to learn about the mole. I'm sure by the end of this video, students will understand the meaning of mole and they can solve questions under mole. Students will be able to know the number of entities contained in substances. Let's start with the definition of mole. Mole, it is the amount of substance which contains many particles or entities, as there are carbon atoms in 12 grams of carbon-12. Is the amount of substance which contains many particles entities, as there are carbon atoms in 12 grams of carbon-12. This is measured in mole, MOL. Students should know that the SI unit for amount of substance is mole and not MOLE but MOL. Students should be careful writing the SI unit for amount of substance, which is mole. There are terms associated with this topic, and the number one term is Avogadro's constant. Avogadro's constant into bracket L. The L is showing that we can represent Avogadro's constant with only the L. There's another representative of Avogadro's constant, which is capital N with capital A as a subscript, but I prefer my student to use capital L since it is just one letter and it will be quick to remember. Yeah, so I prefer my students using capital L. Avogadro's constant is the number of elementary particles, the number of elementary particles in 1 mole of every substance. But we said mole is the amount of substance which contains many elementary particles, as there are carbon atoms in 12 grams of carbon-12. And here we are saying Avogadro's constant is the number of elementary particles in 1 mole of every substance. So if you have a look at the definition of the two, there's a link between the mole and then the Avogadro's constant, which we'll be getting to understand at the later part of the presentation. Note, a mole of every substance contains 6.02 times 10 exponent 23 entities. And in English, everything we say means 1. That means 1 mole of every substance equals 6.02 times 10 exponent 23 entities. This statement meaning that, let's say we take 1 mole of sugar. In that 1 mole of sugar, we have 6.02 times 10 exponent 23 entities or particles. Entities can be called particles. That's why in other books they do call them particles. But here my main thing will be on either particle or entities. So let's see the link or the relationship between the mole and then the Avogadro's constant. That's what we have now. The capital N equals mole times Avogadro's constant. And even from the definition of Avogadro's constant, we get it that the number of elementary particles over that is being divided by mole. So number of elementary particles over mole will give you Avogadro's constant. That's all that Avogadro's constant was talking about. That's all the English we are writing there. This equation is all that we are writing there. So making N the subject, since we don't note N, the capital N, we make it the subject. So making it the subject, we get capital N equals small n times capital L. And we know that capital N equals number of elementary particles. small n equals the mole, and then capital L equals Avogadro's constant. That's all we talking about here. So in our next definition, we're gonna understand why this relationship holds. So let's explore what we just done right now. Calculate the number of atoms present in 1.5 mole of sodium. Calculate the number of atoms present in 1.5 mole of sodium. So what atoms are they talking about? Sodium atoms. Since this thing is, the substance is sodium, so the number of atoms that they are talking about is still talking about the number of sodium atoms present in 1.5 mole of sodium. Question 2. The number of chloride ions present in 65.0 gram of calcium chloride. The number of chloride ions present in 65.0 grams of calcium chloride. And they've given us sodium equals 23.0, calcium 40.0, chlorine equals 35.5, and Avogadro's constant, which is L, equals 6.02 times 10 to the 23 particles per mole. Okay, let's see how we'll do this. Give it to us first. We have the equation capital N equals N times L. As we all know from the definition of Avogadro's constant, we got this relation. Capital in the equation we were given small n to be equals to 1.5, that is mole equals 1.5, and capital L equals 6.02 times 10 exponent 23, which is Avogadro's constant, and this is a constant, so students are not supposed to change or do anything changing any number. This is a constant, it remains constant. Putting the values of small n, which is mole, and Avogadro's constant L into the equation, capital N, that is a number of elementary particles, equals 1.5 times 6.02 times 10 exponent 23. So punching this on the calculator will give us 9.03 times 10 exponent 23 atoms of sodium. Without writing atoms of sodium, your answer may be considered incorrect or wrong. Students are to be careful writing the SI units of the various distance that we do. Thank you. You like it and subscribe.